Okay, so we did the left to right direction earlier. So we did two lines are perpendicular if and only if we did the two lines are perpendicular, then their slopes multiply to -1. So now we're going to try the other direction, which is suppose you've got two lines whose slopes multiply to -1, show that they're perpendicular. All right, so suppose we've got L1 and L2. So here's my L1 again, and here's my L2. And we know their slopes multiply to -1. So let's give the slopes names again so that we can talk about them. M1 is the slope of L1, and M2 is the slope of L2. So we're going to draw that same triangle we did earlier. So I believe we called this point B, this A, and this C. And we want to show that that's a right triangle. So we want to show ABC is right, meaning that this is a right angle right here. But we can't assume, so this angle right here, we can't assume that's right. All we know is that the slopes multiply to -1. But we want to show that it is right. Now it's right if and only if the Pythagorean theorem is true for that triangle. So that is AB squared plus BC squared equals to AC squared. So let's go ahead and plug in our numbers again that we had from earlier. So this is again 1, and so this is going to be 1m1, and this point down here, C, is going to be 1m2. And then we have 0, 0 right here. Okay, so what can we say? So AB squared plus BC squared is going to equal, again, M1 squared plus M2 squared plus 2. So why is this true? Well, it's the same reason we had earlier. You find the length of the red segment, so you find the length of AB over here, and we did that by looking at this right triangle with 1, M1, and AB as the three sides, and the Pythagorean theorem gave us this was equal to the square root, so AB was equal to the square root of 1 plus M1 squared. And then we did the same thing for BC. We looked at this right triangle down here. This was 1. This was the absolute value of M2. And this is BC. It's a right triangle like that. And then we, again, found BC was equal to square root of 1 plus M2 squared. And so this bit right here, this was just the same thing as what we did earlier. All right, so since M1, M2 equals -1, right? We know that their slopes multiply to -1. So this is that M1, M2 is equal to -1 when we multiply them together. Then if I multiply both of these sides by -2, so I'm going to multiply over here by -2, -2, then that's going to give me -2 M1 M2 is equal to 2. All right, so now we can make a substitution. So let's use another color here. So 2 is equal to -2 M1 M2. And so I can replace this 2 with -2 M1 M2, which is what it equals. So AB squared plus BC squared equals M1 squared plus M2 squared minus 2 M1 M2 after doing that substitution. And if you factor this, we distributed it earlier, so we can see that it factors exactly like this. M1 minus M2 quantity squared. If you're not sure that these are actually the same, I encourage you to factor out, FOIL this expression over here and show that it is actually equal to the thing on the left. But this is precisely AC squared because, again, from our diagram, AC right here is just the difference between M1 and M2. So AC is equal to M1 minus M2, just like it was earlier. And so this is equal to AC squared. And so it satisfies the Pythagorean theorem. And so it's a right triangle, so angle B is our right angle. And the two lines are perpendicular. Let's see if I can make this go away. I don't think so. Oh well. Wait, I got it. I figured it out. No, that didn't work. Phooey. Okay, so the two lines are perpendicular.